Hello and welcome to Chapter 11. This is on input and output handling and exception handling. So in this chapter we're going to go over the following: how to read and write text files, process command line arguments, throw and catch exceptions, and implement programs that propagate checked exceptions. So reading and writing text files. You use a scanner class just like we do for input. To read from a disk file, we construct a file object representing the input file. For example, file input file equals new file with the input text. Use this file object to construct a scanner object. We basically pass it into the scanner as opposed to using the predefined one we're used to from system.out. Use the scanner methods read to read data from a file. We can use next, nextInt, and nextDouble, for example. So a loop to process the numbers in a file would look like this. While there are more doubles, grab the next double and do whatever you want with it. To write a file, we construct a print writer object, giving it the file name. If the file already exists, it's emptied before the new data are written into it. If it doesn't exist, an empty file is created. That's kind of convenient, but you got to be careful of that. Use print and print line to write into a print writer. Out.println hello world, out.printf, formatted. You must close a file when you're done processing it using the close command. If you don't, things might not get written to disk and resources will get hanging around. An optional character encoding can be specified to specify UTF-8 usually, or you could use Unicode. There are other options here. When an input file or output file doesn't exist, a file not found exception can occur. To handle the exception, label the main method with the throws file not found exception, which we'll go over how to use. So, reading and writing text files. Example: read a file containing numbers. Here's our sample input. Write the numbers in a column followed by their total. Section 1. Okay, here's our basic program. The next method of the scanner class reads a string that is delimited by whitespace. A loop for processing a file looks like this. While in has next, read the line, or read up until the white space, and print it out. If the input has Mary had a little lamb, the loop prints each word on a separate line. The next method returns any sequence of characters that is not whitespace. Whitespace includes spaces, tabs, new line, and things that separate lines. These strings are considered words by the next method. When next is called, input characters that are whitespace are consumed, basically eaten from the input. They do not become part of the word you receive. The first character that is not whitespace becomes the first character. More characters are added until either another whitespace is found or the end of the line or input file has been reached. If the end of the input file is reached before any character was added to the word, a no such element exception occurs. To read just words and discard anything that isn't a letter, we can use the following. Use the delimiter method, saying that the delimiter is anything that's not in A to Z and A to Z. This is called a regular expression. We're not going to go into detail here. Those, you could look them up. The word separator becomes any character that is not a letter. Punctuation and numbers aren't included either. So to read one character at a time, set the delimiter pattern to an empty string. Now each call to next returns a string consisting of a single character. So this is how we process all the characters. The character class has methods for classifying characters. Is digit, is letter, is upper, is lower, is whitespace. That'll help you use them appropriately. The next line method reads a line of input and consumes the new line character at the end of the line. The has next line method returns if there are more than the next line. That way you don't have to read in each word, you can actually read in the line of text. So here we go. Read each input line into a string. Then we can use is digit and is whitespace methods to find out where the name ends and the number starts. Well, character is digit. Keep going. Here's an example to pull the country name. Use trim to remove our spaces, and boom, Bob's your uncle. Text input and output, scanning a string. Occasionally easier to construct a new scanner object to read the characters from a string. Then you can use the line scanner like any other scanner object. So we create this, and we basically say, go through and get the next one. And it can read from a string itself. notice here, we're not reading from a file in this case. We're reading from another string. Handy. If a string contains the digits of a number, use the integer parse int or double parse double to obtain the numeric value. If the string contains this number, parse int will give you the value. However, the string must not contain spaces or other non-digits. You need to use trim to get around that. If the input is not formatted, an input mismatch exception occurs. If there's no input at all, you'll get a no such element exception. To avoid the exceptions, use the hasNextInt method to precursor it. The nextInt, nextDouble, and next methods do not consume the white space that follows the number or word. This can be a problem. So, for example, country names and that sort of thing. The file is read with these instructions. The second call, nextInt didn't consume the new line, so the next call to next line produces an empty string. The remedy is to add a call to next line after reading the population value. So we read the next line, read an integer, and then consume the next line. There are additional options for printf methods. Formatting flags. Left alignment shows leading zeros, shows a plus sign, enclose negative numbers in parentheses. So to print a table of items and prices, each stored in an array, the item strings line up to the left. We'd say that we want to specify left aligned of a certain width string items plus the using a 10.2 area for the float, so the only two decimals will be displayed. A format specifier has the following structure. The first character is a percent sign. Next are flags that modify the format, such as minus to indicate left alignment. Next is the field width, the total number of characters, including spaces, followed by a precision, but the total is what's made up. The format specifier ends with the format type, such as F as in floating point. So D is for decimal, F is for float, E is for exponential floating, and so forth.